because of the two-focus definition of the ellipse, we're actually able to create ellipses with graph paper that looks like this. Here I've got F1 and F2, these 2 points. And then I've got a bunch of concentric circles around them. So if I look here at this point that they have labeled A, notice how that point is on. If I look from F1 to that point A, it's 1, 2, 3 circles out, so it's 3 units away from A. On the other hand, it's on the second circle. It's on this circle around F2, and it's on this circle centered at F1. So this point, and also this point, are 3 units from F1 and 2 units from F2. Now an ellipse is all the points where the combined distance from 2 foci are the same number. So if that number is 5, these 2 points that are red are 2 points on them. But there are other points also. For instance, these 2 points are 2 away from F1, but 3 away from F2. So they also have that magic number of 5. And while we're at it, this point over here is 1 away from F2, but it's 1, 2, 3, 4 away from F. It's 1 away from F1, 4 away from F2. Here's another one that's 1 away from F1 and 4 away from F2. And here's some points that are 1 away from F2, but 4 away from F1. What these points have in common is that they all have a combined distance of 5 away from the 2 foci. And there's even a point over here, kind of inside the circle. It's half a unit away from F1 and 4.5 from F2. And over here, there's one that's half a unit from F2 and 4.5 away from F1. Either way, we get this ellipse. A little bit easier is this one. This point B is 1, 2, 3, 4 away from F1, and it's also 1, 2, 3, 4 away from F2. So this is on an ellipse whose magic number is 8. So if I want more points on this ellipse, well, first of all, there's another one down here. That's also, make it blue, that's also 4 away from F1 and 4 away from F2. But there's other numbers that add to 8 besides 4 and 1. For instance, if I want to be 3 away from F2 and 5 away from F1, I can go right here. You see, that point is on that point's on a circle that's closer to F2, but it's 1 further away from F1. And if I keep doing that, I get this point here, which is 2 away from F2, but 6 away from F1. Oops. Sorry, these pictures are moving around more than I wanted them to. Here's another point that's 3 away from F2 and 5 away from F1. And if I do this for every combination that adds up to 8, 3 plus 5, six plus 2, again 3 plus 5, I end up with another ellipse. This one looks more like a circle because its eccentricity is bigger. Okay, so those are 2 ellipses that you can make with this kind of funky graph paper with concentric circles. Another thing that we did in class for this lesson was we learned how if you have a circle on a piece of paper and you have the center drawn in, you call that O, and you call some other random point P, and then you take some other random point, put it on the circle, and then you make a fold where you fold this R point, I'll call it R1, onto P, you get this perpendicular bisector. If you then intersect that perpendicular bisector with radius OR, you get a point over here I'll call S1. And if you do that with some other R point, you fold it to P to make a perpendicular bisector. You intersect that perpendicular bisector with OR2 to get point S2. The points will form an ellipse that has foci O and P. And the reason that happens is because if I draw in this line segment S1P, this line segment is congruent, S1P is congruent to S1R. That's because this fold here was the perpendicular bisector of, if I made this line segment here, PR1. So every point on the perpendicular bisector is equidistant from the two endpoints. So those two things are equal. Now, we know that OS1 plus S1R is the radius of the circle. But if S1R is equal to S1P, OS1 plus S1P is going to be the radius of the circle. Now that's also true down here. If I say, if I draw this line segment in, PS2, S2P and S2R2 are congruent to each other, but OS2 plus S2R2 is the radius, same radius, which means that OS2 plus S2P is also the radius. And that's why this thing makes a circle, because for any point, anytime you do this folding thing, you'll get a point where the combined distance always equals the radius.